Hello and welcome everyone. This is Make Design Nepal. Today we will learn how to design ball and socket joint in Solidworks. Here you can see a sample of ball and socket joint in my window. These kind of joints are mainly used in different mechanisms which require 3 degrees of freedom. Like this ball can rotate in 3 different axes. You can see here. So today we will learn how to design this ball and socket joint, and we will also learn how to use this, how to make the ball and socket. Solidworks does not explicitly provide ball and socket joint, but we will try to replicate the movement of ball and socket joint via other methods. So let's begin. First of all, go to new. We will directly work on assembly. Click on assembly, click OK. After that, cancel everything, and we will go from basic assembly tools. Click on insert component, click on a new part. So we will directly start from here and click on front plane. Here you can see a part called part name, part 1. We will right click it and rename this item. We will call this ball, ball, ball. So here you can see a ball is written. Now expand this item, then go to front plane, click on sketch, so we will create a ball. Here to create a ball, go to circle and we draw a circle here. Let's give its dimension as 86 mm. Now here is the ball. Now select on line and draw a line from center of the circle. Then trim this circle, trim the half portion of the circle and go to revolve workspace. From here select axis of revolution as this. Now you can see a ball is made. Now we will design the handle for this ball. For that, go to top plane, click on sketch, click on circle, and then go to get a circle here, and we will give the dimension of circle as 25 mm. Now here is circle. Now we need to extrude this circle. For that, go to features, click on extrude workspace. From in from section, select on surface, click on the surface. Now give the dimension is 70 mm. Now here you can see a ball handle is made. Now let's apply flat here. Click on flat and go to here. See, our flat is also made. Let's apply some appearance to this part. For that, exit sketch and right click on that part, and from here click on space. We are trying to apply appearance on this assembly one only. So ball assembly one, right click here and we will give a red color, this color, click on OK. Now we need to design socket. To design socket, we have to remember the diameter of this circle. The diameter of that circle is 86 mm. So let's hide this part and again click on insert component and click on new part. Now again click front plane and draw a circle here. We will draw the circle with the same diameter, which was 86 mm. Now click on circle, click on line and draw this line as follow. Now we will draw a line from here. Okay, now give the distance of this line from here, and we will give it as 12 mm. Now after that uh, we need to create this circle. For this you have to trim these entities, trim this part and this part. See, it is under defined. Now we will give the dimension again from here and it will be defined. Now this is defined. Now click on features and click on revolve space. Now give axis of revolution is this line. So here you can see axis as of socket type feature has been made. Now we will create this shell. To create shell, here click on 2 mm and give the surface area as here. See, we have also made the socket. Now we need to give the handle for this socket. For that, click on top plane from here. Click on top plane. Sketch a circle at the center. Give the dimension as 25 mm. Again go to feature. Click on extruded boss base. From here select the surface. Click on this surface and give the dimension as 70 mm, and here it is done. So this is done. Now one thing you have to remember is, now let's exit this circle. See, here are both parts are modeled here. Now we need to click on one part and let's make it. Now we need to click on mate and here you can see in place 2. Let's delete one of this. Let's delete both of them so each part can be moved as required. See, now we can move both the parts. Okay, now go to mates from here and press control key from your keyboard and then press front plane. Okay, we will fix this socket. So what we have to do is give the name for this part to right click on this part and go to rename tree item. We will give here socket. Now it's done. Now we need to fix this socket part. Let's give it appearance. Okay, now let's make it like this color. Okay, it's done, and let's change its transparency so we can see the inside portion also. See, here you can see the inside one also. Now expand this socket tree and click control from your keyboard and then press front plane and front plane of that both assembly. Then click on coincident. Likewise click top plane and top plane. Click on control. Likewise click right plane and right plane. Click on coincident. See, now this is fixed and this is movable. Now we have to mate these parts. For that, right click on this part and click on move with right and rotate this part is like this. See, we have now rotated this part. Now we have to do what we have to do is we have to mate these parts. First click on this, press control key and then click the ball and click the inside of the socket and release the control key and you will see here you will see concentric mate. See, we have applied the concentric mate. Now let's check the cutting and fitting of these two parts. Let's change its let's change this transparency again so it will be, see, I have done a mistake here knowingly, so that you won't make this mistake. Here you can see the ball and socket are in same, they are like combined together, but in real there has to be some gap between this ball and this socket. For that we have to decrease the diameter of the ball by 2 mm, because this shell uh, thickness is 2 mm. Let's do that. Then you can edit the part directly from here. Expand this item, we need to decrease the diameter of the circle. Now right click on sketch and save and continue. Let's save as a ball and socket joint. Ball and SOCKET socket JOINT joint. Here let's give it as 84. Now click on rebuild. See, you can see here only it. Now we have to give it as, we have to decrease the diameter by 4 mm, because it is on both sides. We need to decrease it by 4 mm, which is 82. We decrease the, oh, we did a mistake. We did a mistake here. Maybe. No, it's fine. Okay, it's whatever, it's fine. Let's go on. In real, the ball joint movement cannot exceed this line, this point, because because the handle of the ball is conflicting with the surface, this surface, which is the socket surface, because this cannot move like that. Now we have to confine this moment. For that we need to use the angle method. Now let's expand both these items and make sure your socket is fixed. Now this is fixed. Let's go on to top plane. This is fixed. Okay, then click on mate. This is fixed. Now we need to give angle with respect to its front or right plane. See, this is what is our socket. This is socket. Wait, now we need to clear this. We need to select the top plane of the socket, top plane of the socket and front plane of the ball, and click on angle mate. Now go to advanced. Now see, is the motion right? No. Then drag this a little bit. If you can drag from there, change the dimension is here. Now it's 93, we will give it 85. Now you have to check like this, even it's conflicting again. Then decrease the diameter is, let's assume 80, even it's also conflicting, so give it as 70. So you have to find the optimal value where the ball and socket are not conflicting. I will pause the video and find the appropriate value. Also you can do like this. If you can't find the optimal value, then there is another trick which will help easier to find the optimal angle. For that, go to sketch, go to expand this socket and check this sketch and go here and decrease this distance between that chord and center, which let's make it as 20. Let's see. Okay, let's make it as 20. See, now again apply that mate in same order. You can go from here, click on mate, click the top plane of the socket and right plane of the ball. See, and you have to go to advanced and click on mate. See, these two are not conflicting now. Now we have to find the optimal angle. Just drag from here and go to increase angle. Seems like with how much degree is here, we need to go by, let's suppose 50. Let's suppose the angle is 50. Now it's conflicting. Increase the angle 60. See, it's not conflicting. Let's try 58. It's not again conflicting here. So one angle is 50 degree, 58 degree. Now we have to find another angle. What we can do is 180 minus 58, which will be, see, 122 degree. Now we need to give this limit here, which was minimum angle is 58 degree and maximum angle is 182 degree, 122 and 58 degree. So remember this. Okay, now again select the top plane of the socket, and right plane. Let's check the mates what we did earlier. Limit angle, socket ball and socket joint, limit angle mate. We have to, okay, let's check it again. The angle is top plane and right plane. Now we have to select socket top plane and right plane. Now what we have to do is top plane of socket and front plane of ball, and go to advanced, click on this, and likewise give that angle which is here. Okay, see, the mate is confined here. Like this you can design ball and socket joint. If you want more tutorials on designing different parts in mechanical parts in Solidworks, then you can comment, and thanks for watching.